Hello, this is Ron McCullough, consultant podiatric surgeon, director of the London Podiatry Centre. So today I just want to cover in this video the various aspects of gait analysis performed at our centre so that patients who might be interested in undergoing this investigation are well informed as to what we're about and how we go about performing gait analysis for really a myriad of different types of patients. So I thought I'd start by just giving a bit of background information on our facility and how experienced we are in the field of gait analysis. So the facility has been in existence now for approximately 30 years. During that time I've always spent time in the London Podiatry Centre, but I've also consulted for many major teaching hospitals. I was a consultant podiatric surgeon for many years at Hamilton University Hospital, where, as well as performing a wide range of surgical procedures, I also was involved and led aspects of the biomechanics and gait analysis service, and this continues to be a really big part of my practice, partly because, of course, if we can understand gait and biomechanics, we're far more likely to be able to properly solve the problems that we face as practitioners. So really, whilst at Hamilton and also in the universities, I was very involved in all forms of surgery, everything from major reconstructive surgery of the foot to limb salvage surgery, where we try to save the feet and legs of diabetic patients in particular, but also right across the board dealing with mechanical problems, tumours and so on. As part of successful surgery, obviously being able to understand biomechanics and dealing efficiently with optimizing gait is an important part of that. Very experienced in sports medicine, so we've treated many Premiership football teams at our facility and continue to do so. Many years of experience working with Arsenal football team, for example, but also UK athletics, elite tennis players, golfers and so on, really across the whole spectrum of sports medicine. And gait analysis certainly lends itself well to sports medicine, often because relatively small changes in gait can have a big effect on efficiency and performance. I've also been very involved in multidisciplined clinics. So for example, I worked as a co-consultant in pain clinics, in rheumatology clinics, in orthopedic clinics, in neurological clinics, a lot of rheumatology, really across the board. And that's really important because we see a very wide range of patients, and many of our patients present with conditions and pathologies where an integral knowledge of these various disciplines is really important, whether that be because they have chronic pain or because they have a rheumatoid disease or whatever else. And obviously we steer and direct our gait analysis according to what's required in view of the type of conditions that the patient has. So that really gives you a bit of an overview on the experience within the practice. We have a number of other practitioners very experienced in gait analysis within the facility. I lead the team, but I rely heavily, of course, on my colleagues to assist me in the management of patients. So one of the questions that sometimes posed is who would benefit from gait analysis? Well, you could argue in some ways that almost anybody could benefit, because as we all get older, we all become a little bit less efficient in our gait, and there are obviously strong correlations between an efficient gait and a whole wealth of different health variables and parameters. But first and foremost, our patients come and see us because they often have some kind of injury, and often that injury is caused by a repetitive type of stress on the body, and that stress is often to do with the way they walk and function, or the way they run, perform their sports and so on. Or they have a disease process where that's compromised, and if we can optimize gait in various ways, then that disease process can be helped, whether that be rheumatoid or arthritis of a hip or whatever. But obviously in sports medicine, we see, as I say, patients from right across the board, and analysing and optimising gait can have a huge impact on the way that these athletes perform. But I also see children, of course. So there are many parents who are concerned about their children and wonder whether they're developing normally. And we spend a lot of time assessing kids, often just reassuring parents that the response is within normal range. But in some instances, of course, we do see red flags, and there are situations where the child needs to be treated either proactively by ourselves or sometimes in combination with other consultants and specialists. Another area that we're very interested in is aging and fall prevention and really keeping our older patients going and walking efficiently. There's a huge connection between efficient walking and quality of life and longevity. So therefore, this is a big area. We'll be talking about that a little bit more. Fall prevention, I've already mentioned conditions, neurological conditions that we see where we have to manage patients, optimize their gait. So what makes us different? Well, we offer a unique level of advanced technology, and also obviously a wealth of experience. If you count all our practitioners in combination, it probably is not far for 100 years of experience in gait analysis. So we use advanced video analysis. So this is really just videoing the patient and getting information about observation. This is sometimes called observational analysis. It's really useful because the obvious stuff gets highlighted for these type of investigations, but we then do have to cross-reference it against more detailed tests. You can only see certain things, and if it's subtle or certain joints, small joint segments, you just can't see it by videoing. So we do have advanced 3D analysis as well, which we use when we need to analyze further when that's necessary. And we also have various types of pressure systems with hundreds of sensors inside the shoe, mats with thousands of sensors that can measure force, moments, timing, and that's an integral part of gait analysis. It's really combining the measurements that we do with observation, with 3D analysis, and with pressure, force, and time data, and combining all of that together that allows us to form a picture of what's really going on. I think I've said here we're probably Europe's most advanced dedicated podiatric gait facility. I continue to believe that's true. I think you'd struggle to find a gait facility dedicated to podiatry that has the kind of technology that we have. So just to give you a few examples of what I've just been talking about. So if we have a look at this person here, you can see this is just using simple video analysis or simpler video analysis. You can see that the left foot here is very much pointing in and that the right foot isn't. And that's something that I'm just going to go back and just do that again. Yeah, so you've got the right foot here pointing in a much more forward position and the left foot really pointing in. So that immediately we know there's an inefficiency in gait, and this is happening because the person's got an abnormality in their hip, and we can then deal with that. In the same way, as I say, we then need to look at video analysis and just see what's happening with the pelvis. And then we combine that with the next slide, which is looking at the kinematics. So we can put markers all over the body, specialist sensors. These are small sensors called X-Sense, but we also have Vicon systems. You can see how many markers we can put on the foot just to analyze in detail how the foot operates. These are the kind of tests in particular that are done by very few centers. We don't have to do it for all our patients, but when we do, it provides additional information which can just make the difference between fully understanding what's going on and therefore finding a solution to the problem and not fully understanding the situation. This is our X-Sense system. So you can see here, this is actually me walking along the waiting room. And it just shows that we can completely remake me, if you like, as a virtual being. And then from that, we can measure various joint angles and get all sorts of useful information about movement. The interesting thing about this particular setup is that it can be taken out of the clinic, so you can literally walk down the road and we can analyze you. But we also use pressure and force data. So you can see here we're using an in-shoe system to measure the forces and moments passing through the foot, and through that we can evaluate all sorts of things really. Forces and tissue stress are the key thing here. If we can measure that and change it, we can often find that as a result situations improve. If you look at this side, you can see there's a lot of force underneath this forefoot, which could easily lead to forefoot pain. And so once we know that, we can start altering the situation and improving the situation. This is our mat system. Sometimes it's more useful to look at a person walking in bare feet over a mat, and that gives us other data that we wouldn't get inside the shoe and vice versa. And we will use these systems judiciously according to what is required. We also produce these personal video reports. What I've found over the years is that patients often find, long documents with lots of graphs and words a bit difficult to digest, and by doing video reports we find that patients appreciate that, and we're able to provide a transcript and really give detailed information which is approachable, understandable to the lay person to go through how gait is manifesting and what effects it's having. So one of the questions we often get asked is, well, how do we what do we aim to do with gait analysis? What are our objectives? The obvious answer to that is, well, most patients come to us with a problem and we try and solve that problem, whether it be knee pain, hip pain, arch pain, Morton's neuroma, forefoot pain. It could be any one of a myriad of different conditions. And often through Gait, we can see where the stresses are occurring, and as a consequence, we can deal with them and the patient can get better. But it's not just about that. Sometimes the patient has a disease process. It may be that they have severe arthritis, whether it's inflammatory or osteoarthritis, which is wear and tear. They may have a neurological condition. They may have foot drop from a back injury. It could be anything like that. And so we try to improve efficiency. There's no point in resolving somebody's pain if we don't make them more mechanically efficient, because you're just stirring up other problems or potentially creating other problems for the future. The other key thing that we try and do is promote long-term health. And this is really becoming more and more popularized, and people are much more aware of this now, and it's talked hugely on social media about the idea that we all begin to suffer from sarcopenia, our muscles begin to waste a bit, and as a consequence we become older and we become more fragile, we become more susceptible to falls, we could become more susceptible to injury. There's a very big connection between how efficiently we walk and how long we live, and how likely we are to live healthy lives. So our aim is to promote good walking, normal function, so that muscle wastage is minimized, and that's really, really important. This stat is quite shocking in some senses, that there are 76,000 hip fractures per year in the UK, and that it costs around 2 billion per year, and that a third of people who suffer hip fractures unfortunately don't survive beyond the year, and many don't end up leaving hospital because of the complications of hip fracture. Why do hip fractures occur? It's because people have poor balance, poor control, and this is one of the reasons why not only specific rehabilitation, but even certain sports, like for example tennis, is a very good way of fall prevention. People who have played tennis all their lives tend to be able to control their balance and their ability to fall much better. And so it's really all about empowering people with the right biomechanics to be able to continue their sports. Because if we can keep somebody in a position where they're able to continue playing tennis by resolving their injuries and improving their efficiency, they will also potentially live longer. And incidentally, with tennis, it's been shown to be as long as 10 years longer. And they're also less likely to fall and have other problems. So, as I say, numerous studies show a strong association between gait and efficiency, health span, and quality of life. So why have I shown you a picture of a cake and a sports car here? Well, there is a logic behind that. And that's one of the questions that's often asked by patients when they are talked to about their gait deficiencies. Well, that's all very well, but I've had this problem all my life. Why is it manifesting now? Why does the leg length difference have an issue now when it didn't for the first 20, 30, 40 years of my life? And of course the answer is the effects of time, the cumulative effects of having a biomechanical imbalance. So the analogy is, if you eat cream cakes for the first 30, 40 years of your life, you may not have high blood pressure, but eventually if you do develop high blood pressure, it's very likely to have something to do with the fact that you've devoured cream cakes perhaps more than you should have done over the years. And it's the same with biomechanics. If you have, for example, this car, if you were to have a slight malalignment of one of the axles, it would still run beautifully for the first 30,000 miles or so, but eventually something would go wrong, and that would be to do with the mechanical imbalance within that car. The body is a biological machine. It's exactly the same principle. If we have a biomechanical imbalance, over time it begins to have an impact. And obviously if you're a runner and you really push your body to the limits, then perhaps in some ways mechanical imbalance are more likely to show up a little bit sooner in terms of injury. So what we really try and do with gait analysis is to correct, the causes of conditions, but also to improve global efficiency, to make you generally function more efficiently. That's really, really important. And there are several pillars of gait, and they include resolving and dealing with movement issues, actually achieving good symmetry and force, and minimizing tissue stress by not making sure that the pressures and the forces are not excessive. And the other one is balance is really important as well. So we use gait in various ways to assess these three parameters in particular. And we have developed this efficiency score, which is unique to our center in the way that we do that, where we take all that information and we give you a percentage efficiency score. And the higher the score, the more efficient you are. It's not really necessarily even a score where we're trying to achieve 100% because nobody ever achieves 100%, but we're trying to get you as good as you can be. And by giving you an efficiency score, say you score 65, then we know that if we do certain things and we retest you and you go to 75, that we've improved you. And that's one of the principles of doing these type of tests. So what do we look at to achieve optimal efficiency? What do we, in other words, use to look at the score? Well, there's a few things, but if we just look at this foot, the pressures underneath the big toe A, the big toe joint B, and the second toe joint have a direct relationship. They should be similar. If you have very high pressures in any one of these three areas, that will be an abnormality which is likely to potentially cause issues. This line running through the center of the foot is called the center of pressure line. It's the average position of the pressure, and we look at that as well. We try to keep the pressures below a certain amount, in this case 200 kilopascals. In the case of the center of pressure, this is really can be likened to, so for example, standing on a surfboard. If you stand on a surfboard and you're perfectly balanced, you're close to the center of pressure. If you have these two kids sitting on a seesaw and they're perfectly balanced, then the pivot point is the center of pressure. So as you walk, the center of pressure moves forward, and we know what it should be, and we know it should be symmetrical. So we can evaluate the center of pressure and use that to look at mechanical efficiency. This is called a force time curve. This is a really good way of looking at global efficiency. So under normal circumstances, you would have a peak here. This is an M-shaped curve, which is your heel making complete contact, and then maximum contact if you like. And then the push-off phase is where you're pushing off with your forefoot. And as I say, it should be M-shaped. So for example, this patient here has a less efficient force time curve in the sense that there's an asymmetry between the left and the right side and an irregularity. If we look at this one, it's not perfect because the second peak is a little bit high, but it's a much better force time curve than this. So that's the kind of thing we evaluate and try to improve. With regards to balance, we particularly look at something called postural sway, and in particular the distance of postural sway. What does that mean? Well, if you look at this person with a pencil sticking out their head, even though they try to stand still, they're going to have a degree of movement, and that movement can be measured as that line, and it's the length of that line in particular that we're interested in. So the length of the line shouldn't be more than a certain number of centimeters, and if it is, we know it's outside the normal range, and we start working at trying to improve that, because that has a direct correlation to your sense of balance and your ability and likelihood to be able to maintain your balance and perhaps have less susceptibility to falling. So we know what we're trying to achieve. The question, I suppose, is how do we change gait? What we do to change gait? That's obviously going to be a very popular question that we're asked. Well, there's lots of areas here. First of all, there's gait re-education. Okay, it's not simply a case, or it's rarely a case of saying to the patient, you're not walking correctly, do this instead. Because the patient walks in a certain way because that's the best they can walk with what they have. So, for example, if they drop their right hip because they have a leg length difference, there's no point in telling them not to drop their right hip because they're doing it because they have to, because their leg's shorter. But if you give them a raise, you would deal with that. And it's the same in many, many other instances. If they have a weak muscle because of an injury, you strengthen the muscle. If they have a collapsed arch because of instability, you can give them a specialist support if you can't deal with it through strengthening, which sometimes you can't. Sometimes it's a structural problem with the foot. Footwear can have a profound effect. Just simply changing the shoes can have a huge impact on injuries. And we assess shoes technically to make sure that the shoes are optimally functioning. There are many other types of medical appliances we will give according to what's required. And finally, as a podiatric surgeon, sometimes it's necessary to operate in order to remove the pain that's causing the abnormality in gait. Okay, so with regards to specialist supports, so we do sometimes recommend that patients have special supports inside the shoes called orthoses. And the way that these are made is that we take a three-dimensional scan of the foot, and that scan is sent to a laboratory, and then orthoses are made through various types of milling, computerized processes, whether that be 3D printing or milling. But these devices can rebalance the foot and deal with imbalances that we've identified, often in combination with shoes and generally also in combination with gait re-education and rehabilitation. Such devices are extremely thin. They last years and years, easily 10 years plus. And because they're made in a very sophisticated way, they will easily fit into shoes without taking up minimal bulk. As I said, they last many years. And the idea of an orthotic is to generally improve global efficiency, but also to deal with the specific concern that's present. So let's just talk a little bit about rehabilitation. So in relation to rehabilitation, we have on-site physios, we have physiotherapists that actually work off-site for us, and we even have physiotherapists that will work at home with patients to provide them with rehab programs if that's required. Our on-site physios will work specifically with the gait deficits that have been identified and use a whole myriad of techniques to address that. Obviously too extensive to talk about that in this talk because it could be so many different things, but that's their speciality. Okay, so just going through what some frequently asked questions. Difference between treadmill and normal walking. Some patients, we do both. So we get patients walking in their normal environments and we also use treadmill walking. That really just depends. In some cases it's convenient to treadmill, especially if the patient is used to a treadmill, runs on a treadmill or walks on a treadmill anyway, then that's going to be quite a natural gait. There are differences, don't get me wrong. There are definitely differences between treadmill and normal walking, but we factor those in. If you get an asymmetry like a hip drop or an excess pronation, collapse of one arch, that's going to show up anyway, whether it's a treadmill or not. But things like cadence, the length of time that people walk and so on, that can have a more profound effect on, on whether you're on the treadmill or on a normal surface. And as I say, we take that into consideration. And for some patients, a treadmill just isn't appropriate for that reason. Sometimes patients come to us and they say, oh, well, I saw this person, they don't need all this gait technology, they just got experience and they can see and know what's going on. I obviously question that because you can't see force, you can't see timings, you can't see pressure. And even though I've been doing it for 30 years, and I like to think sometimes I can preempt how somebody might walk and run based on a static assessment, rarely would I be able to predict everything. There's always going to be all sorts of things that we can't see, and gait analysis cannot replace a static examination. It just can't. So that would be my answer to that. Some people use 2D, some use 3D. We use both. We use it according to what's required and what the patient needs. And we will be able to make that decision when we see the patient and advise accordingly. Effects of shoes. Shoes have a profound effect. I think I've already mentioned that. Really big impact. And we assess shoes. We look at the efficiency score of shoes. And we always recommend shoes based on the results of our own tests, not on the results of the manufacturers who generally don't provide much information, certainly not on the background of, or on the back of, independent reviews. Because if you look at most reviews of shoes, they're not at all scientific, are they? They're just somebody talking about the shoe in a generic sense. So long-term effects of orthoses versus bare shoe concepts. Yeah, this comes up. So some people will say, well, surely we shouldn't be wearing anything other than just a very simple flat sole with a bag around it because that's natural. And yes, for some people that's great. If you've got good biomechanics, if your feet are very stable, if you run on a mixture of terrains, then having a barefoot type shoe is good, and you certainly wouldn't necessarily need anything inside it. But a lot of patients we see would definitely not be able to cope with that, and they get injured because they don't have the foot structure and the biomechanics to allow them to wear that kind of shoe. Sometimes with the right type of rehabilitation, people can gradually win themselves into these type of shoes, but it really depends on individuals. We're not anti-barefoot shoe technology, and I do use it and recommend it. Some shoes we prefer more than others, and this would probably require a different talk because it's such an extensive subject. But they certainly in some cases will cause injury. In other cases, they can avoid injury. How do we manage children's gait abnormalities? Well, there are cardinal signs that we look at. So we generally look at things like pain, obviously, is a key reason to treat children, developing deformity that we need to try and control, instability, tendency to fall, and so on. These are all key variables that we decide. Sometimes we do see red flags where children come up and we can see there's some dystonia, which means abnormal tone of the muscles. And then, of course, we will manage that appropriately. We're quite conservative with children. We treat if we need to, but often it's a case of advice, the right footwear, sometimes supports. It really depends on the individual situation. So I hope this has been a useful overview for you. It provides a lot of information on our gait analysis process. If you need more information, please do contact the centre. Our website, which I did not write on this slide, which I should have done, is londonpodiatry.com. Our Foot Expert 360 is the YouTube channel that has a lot of information. But do take a look at our website or contact our clinic direct if you'd like more information. Thank you.